So we were looking into Azure architecture and services. And as a part of Azure architecture and services, we discussed VM. As a part of Azure architecture and services, we discussed VM, that is a virtual machine. Virtual machine. We also did an exercise on this, right? Exercise in the last class. So in that exercise, we saw that how will we creating a VM and how we will be hosting a solution or an application onto the VM. So maybe it may be a web server, it may be an app server. So we just hosted a simple web server, a simple application that was a Nginx web server. Okay, a basic one. And we have seen how we can manage the machine, how we can connect to that Linux machine, and also how to uh, run any web server or a web service into that. How to open the ports, how to handle the security group, how to add the inbound rules. Okay, all those we have seen in the VM in that exercise. Also, we have seen VMSS. In VMSS, we have seen the upgrade domain. Upgrade domain. We have seen the fault domain. Now, third kind of service. And what kind of services we are discussing here? Compute. Okay, compute services. And that too mainly it was falling under IaaS type. IaaS category. VM and VMSS. Third type of service we will be discussing about AVD. What is AVD? AVD is Azure Virtual Desktop. It's a very simple service. Actually, this service provides you a facility that you can connect to your system which is available at your home, okay, at your place, and you can access your system from anywhere around the world. That is Azure Virtual Desktop. So you can access your system from anywhere around the world over internet. Now, what is this type of service basically? For example, you are at your home location. Okay. And it at your home location, you are having a desktop or a laptop, can be anything. You are having a desktop. In this desktop, you will be having an AVD from Azure, AVD service or AVD client, okay, installed. AVD installed. And you need to keep this system always on. So when your system will be always on and you are traveling, okay. Suppose you are in other city, other state, other country, anywhere. Okay. This is remote location. Remote location. Remote means far from your homeland. Okay. Remote location. Any location it can be. A city, a country, anywhere. So what you can do over the internet using your Azure account, Azure portal. So using your Azure account, you can use this AVD service. So you will be having a VM here. VM means you will be having a virtual machine. Using this virtual machine, you can connect to your system. Using this virtual machine, you can connect to your system. You can have a connection to your system sitting remotely. Using the virtual machine, you can connect or you can access your system at home location. So that type of service is AVD here. Azure, that's why we call it as Azure Virtual Desktop. But there is a condition. The system at home should always be on. Okay, if it is off, you cannot access that. That should be on. Apart from this, they are giving some features here. Now, generally, you can connect using remote login anywhere. Okay. But that remote login will not give you other features. Hello, am I audible to everyone?
Yes, Abhishek.
Yeah.
Yes, Abhishek.
Okay.
Yes.
So there are some features which are coming with this AVD, Azure Virtual Desktop. Those features are users can do concurrent login. Concurrent login. And have multiple sessions running at a given time. Means if two users want to connect this desktop at home location, they can perform it concurrently at any given time. At any given time. Means users can have multiple sessions onto that machine using AVD. That feature you will not get with a simple connection or simple remote connection to that computer. Only single person can be connected to that. But using AVD, you can do that. That is a feature. Okay. There are some other features also, like additional security. While accessing the remote desktop from the AVD, you will not get the protection over the internet. For example, you are accessing that machine over the open internet. Okay. What you can do, you can privately access your desktop. Okay. You can privately access your desktop using a private network instead of public network. So that is a kind of additional security you get. So you can connect your machine remotely over a private network. Over a private network. You don't have to connect it through a public network. Okay. Also, you will get protection against threats. against threats. Okay, like DDoS kind of attack or threats and attacks. These protections you will get additionally. These some of the features you will get over here with this AVD. So that is a kind of simple service AVD is. You can use that if required. Okay. Apart from this, in compute services, if we talk about PaaS category, means platform as a service. So we have containers here. Containers. What are containers basically? Anyone? What are containers?
Storage.
Not storage.
Containers
Containerization,
are having code
software
and
virtualization.
So you are terming this as containers in the storage account, right? Azure storage account.
So it's like virtualization, software virtualization.
Mhm.
It's like a package of codes or something.
Like what we
Actually,
use in
actually,
Docker.
actually, container is a runtime environment. Okay. Now,
So Docker is also a
Is it
container, no?
that
offers
Docker one will be.
configuration?
Come again.
Offers a configuration
Offers a
and
configuration, definitely. See, earlier for hosting any kind of application, okay, we mostly relied on the specific solutions like virtual machine. Okay. So earlier we rely on specific hosting solutions like a physical machine or a virtual machine. Or a virtual machine. Means, for example, if I need to deploy any kind of web server or app server, first I need to create a physical server or I need to create a virtual server, physical machine or a virtual machine, and then I need to install. Then I need to what? I need to install. What I need to install within that? A web server. For hosting any kind of website, I need to install a web server. Or for running any kind of application, I need to install an app server. And then over that app server, I deploy my code. Deploy my code. That was a common hosting solution. Physical. Now, what is the issue with this common hosting solution? So I'll tell you the drawbacks here. Drawbacks. So the drawbacks with this common hosting solution was it runs on full operating system, full OS. It runs on full operating system. Now, what is a full operating
Full,
system?
sorry to interrupt. Full operating system means
Ah,
I need to install whole operating system.
Full operating system means, for example, you can see my laptop screen, right? Now, my laptop, in this laptop, in this PC, you can see there is a C drive, which is my operating system drive, right? And then there is
Yeah.
a D drive and E drive, which are storage drives where I can store anything, right?
Yeah.
So in the C drive, you can see what amount of space is used by my C drive. So almost somewhere around more than half of the space is used by my C drive. And why it is used? Due to the drivers and the files which are
Essential
required to
files.
run my operating system, right?
Yeah.
Means every time my application will load, first I need to load my whole operating system and then my application will load, right? So
Yeah.
for loading this whole operating system, it takes a long startup time. Means whenever I will be deploying any application, I need to restart my system, right? So whenever you install any software, what is recommended? Please restart your system, right?
Hmm.
Why is that mandatory? Because everything will be in sync with your operating system once you restart. But if you do not restart, some files may not work, right? Because they do not sync with the operating system. So to properly sync those files, whatever you have installed with your operating system, you need to restart once. So that is recommended process. So the same way, whenever you are installing anything and you are deploying any code, so after the deployment, it should start up, okay, or come up. So that startup time takes very long whenever you run any application on a full operating system. Now, in this full operating system, now whenever I'm deploying anything, either I'll deploy it in a web server or I will be deploying it in an application server. Now, what are these web servers and application servers? So web servers, when you run a single page application, for example, in that application, I have only the source code. Source code means the code which is written by developers, source code on which the application runs. So source code cannot alone run your application. You need some dependencies to run that source code. These dependencies comes in the form of packages. Packages. For example, I am running a Java application. Java application means based on source code Java. Okay. Now do not consider this as you need a development or a developer knowledge. Okay. It's just for an understanding. So everyone knows what is Java. It is a language. Okay. And the source code, the code on which the application is developed, that is based, for example, that is based on Java. So that is a Java application. Now to develop this Java application, I need a source code, which is definitely written on Java. All right, Java. Okay. Plus, I need what? The dependencies. And how those dependencies will come? So those dependencies will come in the form of packages. What kind of packages? Example, for example, dot jar. Okay, just consider this an example. Dot jar, example, dot jar is a package. This package is needed to develop that Java application. And from where we will be downloading these packages? Say from a repository. Okay, from a repository. For example, if we go to Java website or Java dependencies, there are packages, jar packages. Okay. So you can download it from there and you can mix that dependencies. So first we will download those dependencies in the form of packages, and then we extract those packages and we merge that with our source code. And by combining these two, we create a new package. By combining the source code and dependencies, we create a new package. A new package called artifact. So whatever is generated due to these two is known as artifact. And if it is a Java artifact, then it will be in the form of dot jar. It will be in the form of dot var, or it will be in the form of dot EAR. These are the artifact files. And to deploy these, again, I'm saying you cannot directly deploy the source code. First, you have to combine it with the dependencies, and then you need to create an artifact file. And that artifact file can be deployed either on a web server or an app server. This artifact can be deployed on a web server or an app server. So generally, when we have only source code and the dependencies and we create an artifact, that we deploy on the web server mostly. But whenever you are having the source code, plus dependencies, means the packages, plus you want to give a nice styling to your website, style sheets and all those things. So what is that? CSS, cascading style sheets. Okay, you are giving a good design to your website and all. So you will needing a CSS. Okay, so source code, dependencies, CSS. Definitely one more thing here. Plus HTML. Without HTML, you cannot do that. Okay. So source code, dependencies, HTML and CSS. When you are combining all these, so then you create packages like var, okay, dot var and dot EAR. EAR means enterprise application. Okay, EAR means enterprise application. So these type of applications are deployed in app server. So web server and app server. So example of web server is, I showed you in the last class, example of web server. Okay. Now I have given you an example of Java application. That does not mean we can only run Java application. We can run .NET applications as well. We can run Node.js as well. We can run any application. These are just the technologies. Okay. Java technology, .NET technology. Okay. Node technology, React, whatever. These are just technologies. Okay. So example of web server. In the last class, we have seen In Linux system, we have Nginx web server. In Windows, we have IIS web server. Okay. So these are some examples in Linux as well as in Windows. Now, these are web servers. Now, when we are talking about application servers, there are many application servers in the market. Example, Tomcat by Apache Foundation. Tomcat app, this is an app server. Okay. Then JBoss. Then Wildfly. JBoss is by IBM. Okay. Wildfly. These are some well-known application servers in the market. So what you need to do, you need to install these application servers. Like you install that web server in the Linux machine, the same way you need to install these application servers. How you will install? Simply you will go and download, like you always download the software and the hardware, or sorry, the software, other softwares. Like either you download a exe file, a binary file, either you download a MSI installer file, and then you install it. As any other software you install, similar way. So if I search for Tomcat here, Tomcat download, you can see there's a Tomcat website. Okay. Is an application server provider, app server provider. And you can see the versions of Tomcat, Tomcat 11, Tomcat 10, Tomcat 9, all these. And what you can download? You can download the binary distributions. Binary means you can see, you can download the zip file, you can extract the zip file, and from the zip file, you can extract that package and you can install Tomcat. Okay. So there are different versions of Tomcat given here. Whatever is needed by you, you can directly download. Okay. Now you can download it for Windows machines as well. Okay. If you have a Windows machine, you can download zip package. Okay. Or Windows zip package. If you have, or an installer package. Okay. If you have a Linux machine, you can download tar.gzip. Okay. So in both the operating systems, you can download. Once you download, once you install, it will be installed in your system. Inside the program files, you can see this Apache Software Foundation. So this is my app server. So I click on that app server. Inside that, you can see Tomcat now 9 is installed. And inside the Tomcat 9, you can see the whole environment which will support my application. Means what I'm saying is that this Tomcat folder in itself is an operating system which can run my application. Whatever I said till now, everyone understands that?
Yes,
This,
Abhishek.
Yes,
this
yes.
operating system handles my whole Windows system. Means I can run number of softwares. But at what cost? 115 GB, right? But on the other way, if you see this Tomcat folder, what is the size of this Tomcat folder? 29 MB. And I can deploy my jar, var, EAR files inside this Tomcat folder, inside this application. You can see this. I created one sample application, and out of that I created this artifact .var, and I deployed this .var in my Tomcat. After deployment also, you can see the size of my Tomcat folder. It is around 25 MB. So what is this? This operating system, this is also an operating system in itself. So this application server directory is also an OS, operating system in itself, because there are all the files which are needed to support my application. This application server directory is also an operating system for my application. Just give me 1 minute. So this application server directory is also an operating system for my application to run without any dependency. Why without any dependencies? Because all the dependencies are here only. Whatever the files needed to run. See, there is a binary folder, there is a configuration file folder, there are libraries, there are logs, there are temporary folder. Okay, everything is here. All the dependencies which are required to run my application, everything is inside this Tomcat folder. So that means this folder becomes a minimal operating system for me. This Tomcat folder becomes a minimal operating system for me.
We can say that blueprint also, no?
Come
Blueprint
again.
of OS. We can say that it is a blueprint of OS.
It is a blueprint.
Blueprint
Blueprint can
can
be.
be.
Huh. Okay. So this is what a minimal operating system is. Means only those things are required which are required to run your application. That is it. Okay. So when you were deploying your solutions in the traditional way inside the physical server or the virtual machines, then there were two drawbacks. It runs on full operating system. That's why it takes a long startup time. And also was one drawback as well. Cannot be shipped. Okay. Cannot be shipped. Is a major drawback. Shipping. What do you mean by shipping? Means I cannot send this whole operating system. For example, I am the developer and I am working. and it is working fine in my machine. So I cannot send the whole operating system to the tester, to the testing team to test the application. Can I send this whole operating system to the tester?
No.
But definitely I can send this one, right? It's a very small folder, 29 MB only. So I can send this environment, whole environment to my tester, right? Testing team. Also, there might be some dependencies which will be needed. So what was happening earlier, there is a developer and then there is a tester. So the applications which are running in the developer machine, for example, developer is having Mac operating system, okay, Apple laptop. Tester is having simple Windows laptop, HP or Dell or any. Tester is having Windows. Now, when the developer is testing the application, in his Mac OS, it is a success, means he is able to test it successfully. But when the same thing is tested by the tester in the Windows laptop, it is a failure. So now what will happen? Ultimate thing will happen. So developer will say to the tester that you are at fault, and the tester will say, no, 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 you are at fault. The code is wrong. You need to rewrite the code again. So ultimate thing will happen is the blame game here. So to avoid this, they come up with an environment. Okay. To avoid this, they came up with a solution known as containerization. Containerization. So in containerization, what they are doing? In containers, they use to package everything. Means source code plus dependencies plus application environment. So if I take the example of Java, if I take the example of Java application, what I'm packaging here? I'm packaging source code that is on Java plus dependencies for Java, that means the packages, plus Tomcat. So I'm combining all these and I'm creating a package. Create a package combining all the three.
So you're creating artifact, right?
Yes, I'm creating artifact. Okay. So create a package combining all the three here. And run it as a container. As a container and ship it as an image. So create a package combining all the three and run it as a container in your system and ship it as an image. So what the developers and the tester will be having at their ends, they will be having the image. This is a developer. He will also have the image. And the tester, he will also have the image. And they can run this image as a container. Run this image as a container. Where they will run? As a container in the containerization software. Or using the containerization software. So run this image as a container. So developer can also run that as a container. Tester can also run that as a container. And both are having that containerization environment. And there is no difference in the containerization environment of Linux or Windows. Both are same. Because they created a dedicated environment. So now what developer can do, he can test in his Mac system and he can ship the image. How he can ship the image? So he can push the image to where? To some kind of central server, central repository. Everyone has heard about GitHub, right? Where the source code is kept by the developers, right? So there can be a central server where they can put the images, and from that central server, testing team can download the images or the operations team can download the images to deploy it as a server, application server. So from here, from these drawbacks only, they are coming with a containerization environment. So containerization environment, popular containerization environments are Docker. Okay. Popular containerization software. Docker. What is Docker? Docker is an engine. Docker is an engine which creates containers. Which creates containers based on the Docker images. These Docker images now when I say images, connect those images with this, right? Where I am creating this source code and dependency plus HTML plus CSS application server, everything.
Yeah.
Okay. So these Docker images are created using a file called Docker file. So basically what we are doing here, whatever I mentioned here, we will have a Docker file. We'll have a Docker file. And inside that Docker file, we will write the keywords or the commands, right? So this is a Docker file. Now take an example. I want to run a Java application in the Tomcat server. So what I'll be needing here, I'll be needing a Tomcat. Okay. So I'll be needing a Tomcat here. So for Tomcat, what I'll do, I'll refer a base image of the Tomcat. Where I'll get that base image of Tomcat? So since I'm using Docker, so Docker is having its own repository that is known as Docker Hub. And in this Docker Hub, for different softwares, we have different images. For example, I can search Tomcat image here. Tomcat image. Okay, so these are the repositories. Under this repositories, you will find Tomcat. So let's find the Apache repository. Okay, the company itself might be having a repository as well. So these are some users which are having their open repositories, public repositories. But I'll go for the Apache only. Apache Tomcat. Okay. Couch, Niffy, Airflow. These are the repositories of Tomcat. These might be having Tomcat image or not. Let it be. Let's search for any of it. No issues. See these Simran, Shweta, these are the people who have created public free repositories. You can use their images. They have created Tomcat images. Okay.
Don't we have security issues with respect to the
Ah,
data?
we have. So what we can do for that, we can create our own image. No issues. You can create your own Tomcat image and use.
Okay.
Okay. So for example, this is the Tomcat image. Oh, well, it's deleted. Let me show the images itself. See, Nginx images are there. Alpine. Ubuntu operating system images are also there.
Right.
Why it is showing like this? They have changed something in the Docker repository. Earlier, I used to search Tomcat. There are a lot of Tomcat images directly come to the Docker official image.
Maybe do we need to select any categories in the bottom?
I'm just checking that. But asking for a filter. Let me go back. Be public, not be public. Verified publisher, sponsored. You can see these are the images from Tomcat. Okay. See, you can see a lot of images are there. These are one category. These are Tomcat 11, Tomcat 11, Tomcat 11, Tomcat 10, 10, 10, 10, 10, Tomcat 9, Tomcat 8. Okay. Tomcat 9 is the last one. 8, Tomcat 8 is deprecated. So Tomcat 9, 10, and 11. And if you click on any of the repository, they will redirect you to the code. So if I click on any repository, see, I am redirected to where? To the code. Where is the code? In the GitHub. So some of the developer, like for Docker library, has put this Tomcat code over here. And how they are building that image, you can see there is a Docker file. Can you see this Docker file? Right? So based on this Docker file, they have created that Tomcat image. Now there is a basic thing that Tomcat is based on. Okay. For Tomcat, we'll choose a base image. Okay. Now, either the base image can come from a public repository, public repo, or it can come from a private repo. But for the private repo, you have to build your own Tomcat image. Private repo. So how to build a private repo, or sorry, how to build a Tomcat image? So like we are building here this image for deploying our application where we are using Tomcat, and we are also getting our code from the GitHub. Okay, so we will clone our repository, clone our repo from the GitHub. Means we are cloning the code. We'll just write clone the code. So we have the Tomcat, we have the code, and then we have the dependencies. Means we have downloaded the package in the same image. So how we are doing this? So by using some keywords, those keywords are known as DSL keywords. Okay. So DSL keywords means domain specific keywords. Okay. I'll explain you all those keywords when we will be learning Docker, because if I'll go and explain now, it will be a difficult thing to consume each and everything at this point of time, since we are learning only fundamentals. Okay. So don't worry about all these things. I'll clear that. Okay. So you will run this Docker file. As of now, just understand that we will run this Docker file. Okay. And if you want the base image, you can take it from the private repo. You can create your own Tomcat image. So to install a Tomcat or to create a Tomcat image, since the Tomcat is based on Java, you need a Java base image. Okay. So you can download that Java base image from the, you can say, Java certified repository. Okay. You can download that base image from the, so to create an image, you need a base image. Okay, so that's how you create an image. So using this Docker file, I will create a Docker image. Docker image. So Docker image is nothing. It's a package. It's a package having, again, source code plus dependencies plus the application environment to run that application. So that is a Docker image. And this Docker image, you can run it as a Docker container. So this Docker image can be run as a container. How you will run it as a container? Using Docker commands. Okay. So what are the commands? For example, you are building a Docker image. So for this, command will be example. Just for an example, command will be Docker build. Docker build. So using Docker build, you can build a Docker image. So how you will build the Docker image? By mentioning the file name. For example, -f Docker file. So using the Docker file, you are building this. Using simple one command only, you will build it. Okay. So Docker file you will be getting from the developers. Don't worry. Okay. You just need to build it running simple commands. Okay. Docker build -f Docker file that will build a Docker image. And for running this Docker image as a Docker container, you will run the commands Docker run. So Docker run will run your image as a container. So what is a Docker container? Docker container is the runtime environment of a Docker image. Means whatever is packaged inside the Docker image, when you run that, that becomes a Docker container. So now this is what we have this is known as the containerization software. This is known as containerization. That is known as the container. Now, if we talk of Azure, in Azure, we have or Azure have its own containerization services. And those containerization services are first Azure Container Instance. Container instance. And another service is Azure Container Apps. So Azure Container Instance runs a single container application. Azure Container Apps runs multiple container applications. Means any application which needs a single container to run, they are known as monolithic architecture. They are based on applications based on monolithic architecture. And applications based on microservice architecture are run on container apps. Microservice. Monolithic architecture means single code base. Means front end, back end, every code is written in single file. That is monolithic architecture. Microservice means different code files are written for different services in a system. So for example, for front end, there is another code written for front end, separate code written for back end, separate code written for APIs, and at last you are combining everything and running it as a microservice architecture. So that will be needing multiple containers to run multiple services. And single monolithic application can be run in single container. That is the difference, Azure container. But remember, since containerization environment was developed by Docker, the base is Docker engine only. Means even Azure is having its own containerization services, but the base is Docker only. Okay, you will need a Docker file here also to build an image. So the base is Docker engine. Anyhow, so anyone who is developing its own container services, maybe it is AWS, maybe it is Google Cloud, maybe it is Azure, The base is Docker only. So from this is how the container comes into picture. So now what are the advantages in the containerization environment? Advantages. What were the drawbacks over there? So drawbacks were it runs on full operating system, hence takes a long time. So advantages are runs on minimal operating system. Takes short, or what you say, less or short startup time. So whatever the drawbacks were there in the traditional hosting environment, those are overcome in the containerization environment. So Azure Container Instance, Azure Container Apps are the two examples in Azure for containerization services. So that's what the containers are, or that's what from where the containers came in. So in compute services, in infrastructure category, we have virtual machine scale set, we have Azure Virtual Desktop. Same way in the platform as a service category, we have containers. Okay. So that will be it for today. I'll continue with this. Okay.
Sure, Abhishek.
Tomorrow, maybe everyone.
Okay.
I'm okay.
Tomorrow,
I'm okay also.
tomorrow at
Yes,
9:30.
I'm also okay. Tomorrow
Tomorrow at
9:30.
tomorrow 9:30. Okay.
Okay.
Okay, okay.
Abhishek, what will be the duration for tomorrow? Is it 2 hours or 1
No,
hour?
tomorrow 1 hour only. Sunday will be 2 hours. Okay.
Okay.
No worries. Okay.
And Abhishek, one question: if we use this containerization, if we use one for deployment, one image is used, and can we save that image for the next time? Same kind of deployment. Can
Yes,
we
yes,
use it
definitely.
as template? Yeah,
Definitely. We can do.
we can do that. Okay. Thank you so much.
Okay.
All right. So see you at 9:30 tomorrow. See you all.
Sure.
Thank you, sir.
Everyone 9:30. Okay. Remember.
Sure, sir.
Okay, okay.
Okay.
Yeah, thank
Thank
you.
you.
Thank you.